called right there? What is this? Alpha. Okay, so the acceleration alpha of a body moving in a straight line is given in terms of t by alpha equals 8 minus 6t. If the velocity of the body is 25 at time equals 1, and s of t is the distance of the body from the origin, what is s of 4 minus s of 2? So theoretically, you could do this by finding s of 4 and subtracting it from s of 2. So let's just figure this out for example. I don't need to pause it. So, draw. Okay, so we have alpha, acceleration is 8 minus 6t, right? So therefore, what's our velocity in terms of t going to be? 8t minus 3, sorry, I'm writing 2 for some reason. I don't know. Sorry, it's been a while. 3t squared plus, yeah, because you have to take the derivative, right? Plus constant 1, right? Now, the thing is, you need to know what that constant is. Does it tell you how to figure that out? It tells you the velocity is 25 when t equals 1. So you know that v of 1 is equal to 8 times 1 minus 3 times 1 squared plus c1. But what does that have to equal? 25, exactly. So you have 8 minus 3 plus c1 is equal to, so c1 is equal to 20. So now every time you do this, I highly recommend just ejecting back to what you were trying to find before, which was what is the velocity. You now can accurately describe the velocity as being 8t minus 3t squared plus what? 20. Now this right here represents, just to give you the short way of doing this, that's the position at 4 minus the position at 2. What's the relationship between the position function and the velocity function? Exactly. So the way you can think about this is s of 4 minus s of 2 is just the integral from 2 to 4 of v of t dt. That's all it is. You could integrate, no look, you could integrate each, you could just integrate this and do it, but I just want you to notice that that's what that is, right? You're going to do the same work, but that's just something you can say. So if you want to integrate this, what do you end up with? 4t squared minus t cubed plus from 2 to 4. You do this out, minus 848, like this. So what do you end up with? 32, and is that one of the answers? It is. And what they're telling you that the culture is growing at a rate of 3,000 e to the 2t over 5. So you can kind of treat that as a velocity. That's the velocity of the population of bacteria. Does that kind of make sense? So if they're saying, basically, they're saying that this is the velocity at time t of the rate of growth of the population of bacteria. It's telling you that at time equals 0, the bacteria present was 7,500. You need that. Why? Because if you anti-differentiate a rate of change, you get the population, right? But then what do you get tacked on to the end when you anti-differentiate? A constant. This allows you to solve for the constant, and then you can just plug in t equals 5. So the way you can think about this is, well, yeah, so look, the way I would write this down, you have the velocity, I like thinking of it that way, is 3,000 e to the 2t over 5, right? So the actual population, you can say p of t, what's that going to be? You have to anti-differentiate this. You can integrate this, it's not that bad. When t equals 5, so we know p of 5 is equal to 3,000 times 5 over 2 times e to the what? 2, right? Let's just square it because you plug in 5, it cancels, right? Plus c1, and what does that equal? No, 7,500, right? So you have 15, and this is just 7,500, right? E squared plus c1 is equal to 7,500. So what should you, what do you do next? What do you want to do? Divide everything by 7,500 or what? Move the c1 over, right? Yeah, so you get c1 is equal to 7,500 e squared minus what? 7,500, right? I just moved it over to the other side. Is that okay? I think it's okay. Oh, is it the other way around? Oh, you're all right. Okay. Step back. Is this good? Is that better? Is that okay? So, I mean, again, what would you usually see it as? 7,500 times what? 1 minus e squared. Okay, so there's your C1. So what do you have here? Your population times t is equal to, well, it was, what is it, 15 divided by 2. So it was 7,500, right? E to the 2t over 5 plus what? 7,500 times 1 minus. It's 3,000 times 5 over 2. 15 divided by 2 is 7,500. Okay, we're doing okay so far? What does it tell us? The population. Oh. Yeah, we just, I mean, it luckily came out kind of nice, or we might have done something different, right? You understand what I'm saying here? Look, do you see what the problem is? What did we plug in? 5, right? Does that actually help us out at all? At least that helps. Okay. Great, it's great. It's going to be there now instead of like some nice overlays to some random Christmas tree. So kids, P of 0, right? So instead of 5, what do we have to put in here? Is that going to be a lot nicer for our constant? Yeah, so what do you end up with? What is C1? 0. Right? Because this is 1, you get 7,500 equals 7,500 plus C1. Great. So now we have P of t is equal to 7,500 e to the 2t over 5 plus 0. So it's just this, right? Are we okay with that? So now what do we plug in? 5. And is it nice? That's about as nice as it's going to be. P of 5 is going to be 7,500 times e what? Squared. And let's just look. Is that one of the possible answers? Yes, it is. Are there other ways to do it? Use substitution. Yay, okay. So what do we have here? U is equal to what? X squared plus 2x. What's du going to be?
Du is going to be
2x plus, which is, oh, times what? Times dx, right?
Yeah.
What can you factor out? 2 times x plus 1 dx. So what does dx equal? 2 times x plus 1. Well, it happens. X plus 1 times e to the u times du, and you plug out the 1/2 over what? X plus 1. What's the nice magical thing that cancels? They go away. You're really happy about it, right? You end up with a 1/2 integral of e to the u du. What do the limits of integration become? Remember, u is equal to x squared plus 2x. So you plug in 0. Plug in 0, what do you get? Plug in 1, what do you get? 3. Right. So you end up with 1/2 e to the u from 0 to 3. So you end up with 1/2 times e cubed minus e to the 0. Famous thing is that e to the 0 is in fact what? 1. So you have e to the 3 minus 1. So what do you end up with? Let's just see what the possible answers are. Is it there? Yeah, it is. Here we go. So on this one, it's asking you to find dy dx. Is this a function as written, do you think? Really doesn't look like it. You got an x times a y inside the tangent function and an x on the outside. Kind of complicated. So it's asking you to find the first derivative of y. The first derivative of y. What kind of differentiation are you going to need to use? Implicit differentiation. What's the derivative of tangent? So you end up with secant squared of xy, right? Times the derivative of the inside. So I'm just going to write it like that for now. Equals what? Equals 1. Okay, so now if we're taking the derivative of xy, what do you have to use? Yes, so you end up with secant squared xy times the derivative of the first times the second plus the first times the equals. So now what are you trying to isolate? Yeah, you're just trying to isolate y prime, exactly. So what are you going to have to, well, you're going to have to clean this up. So you have to get it in the form that they want. How do you want to clean this up? What do you want to do first? Yeah, you could do divide. So you end up with y plus xy prime is equal to 1 over secant squared xy. What is 1 over secant? What is 1 over secant? Secant is 1 over cosine. So what's 1 over cosine? So you end up with y plus xy prime is equal to cosine squared of xy. So that's where that comes from. So then you end up with xy prime is equal to cosine squared xy minus y. So y prime is equal to cosine squared xy minus y all over. And then you over x, right? Is that there? It is. It's right there. Now, question. They give you some other ones, and they usually give you possible answers that you could get if you did like 1 or 2 things wrong. This one's really close, right? How do you get that one? You don't do the product rule. It'll end up with one of the pieces. Yikes. Okay, so you got a derivative there. You're trying to take the first derivative. So what's the derivative going to be? Y prime is going to be equal to what? What drops down in front of cosine? So you end up with 2 cosine x times what? negative sine x minus 2 sine x times what? Cosine x, and you end up with sine cosine, right? So what do you end up with? Negative 4 cosine x. Oh, I'm sorry, excuse me. Yeah, sorry, excuse me. Excuse me. What can I factor out of each of those? I think you're absolutely right that this is equal to what? Sine of 2x. So which one is it? C. As an example here, new idea here. You had a bar graph. So let's say you had, here's the first test score, here's the second, here's the third, here's the fourth, here's the fifth, here's the sixth. What did you do? You added them all up, right? That's functionally equivalent to finding the area under that curve. You just found the area under that curve. This is kind of hand-waving. I'm just trying to get you to connect the two here. And then what did you do? You divided by the number of students. In this case, the number of students, let's say this was x equals b right here, and this was x equals a. So this is a and this is b. Let's just say that this right here is f of x. How do you think you write the average value? What do you have to find first if you wanted to find the average value of f of x? The what? The integral of f of x dx from what to what? A to b, but then what do you divide by? Exactly, you're dividing by b minus a. That right there is the average value equation. All you're doing is you're finding out how much of something you have underneath the curve, and you're dividing by the width. Another way to think about it is this. Let's say I had a really simple motion problem where I had, let's say this is time and this is velocity right here. Let's say this was the velocity. Let's say it was a constant velocity like v equals 5. And let's say I wanted the average velocity from time equals 3 to time equals 5. What's the average velocity from time equals 3 to time equals 5? Or 6? 5, right? It's 5. Okay, so what happens, kids, if I did this? So I picked the midpoint right there and I just did this. So let's say this was the velocity function right here. This is the green is the new velocity function. If that was exactly the midpoint, so that distance is the same as that distance right there. Sorry, I didn't do that very well. Those two distances are the same, and you have the slope like that. If it's the midpoint, what's the average velocity now from time equals 3 to time equals 6? It's still 5, because what did I do? I took this amount and subtracted it and then added that much. So has the overall area under the curve changed? No, the width has stayed the same. The area under the curve has stayed the same. So therefore, the average velocity is 5, exactly. So the idea here is all you're doing is finding the area under the curve and dividing by the width to find the average value. So on this one, what are you doing? Can someone tell me what the integral is going to be that you're evaluating? It's going to be the integral from what to what? 0 to 2 of x squared, square root of x cubed plus 1 dx. Well, what goes on the outside? Yeah, evaluate that for me. Go. Okay, kids, so what should I make u equal to on this? What should u be? X cubed plus 1. So what does du equal? So dx is... So now you have 1/2 the integral from 1 to what? 9. 1 to 9. X squared square root of u times du over... What's the magically delicious thing that can... Oh, those go away. Is that nice? It is really nice. And what do you end up on the outside? 1/6, 1 to 9 of u to the 1/2 du. So you end up with 2/3 u to the 3/2 with a 1/6 right here from 1 to 9. Simplify a little bit first. You end up with 1/9 u to the 3/2 from 1 to 9. Is that right? 1/9? Yeah, I think so. So you end up with 1/9 times 27 minus 1. So you end up with 26 over 9. Is that one of the answers? It is.